Alright boys, as promised we're looking at trig equations today. Alright, so just like any other equation, trig equations involve a variable and we're trying to find the value of that variable. Now, let's say we have something like this. Cosine of theta equals a half. And with the trig function, what we'll always find, we haven't done this with sketching yet, but we will do next term. If we look at the graph of cosine theta, it looks something like this. Keeps going infinitely in both directions. So with a trig function, we've always got what we call a domain. So there's always some restriction on it. So I'm going to say it's between 0 and 360. Okay, well we know cosine theta equals a half. That's an exact value. We know that our first solution is theta equals 60 degrees. Okay, well we've also got to look in the place. We notice here that this half is positive. So where is cosine positive? Well, cosine's positive in all stations to central. Well, this is our all solution. So our second solution is going to be down here somewhere in the central quadrant. So the other option is that theta equals, well, to find an angle in the fourth quadrant, we went 360 minus. So it was 360 minus 60, which is 300 degrees. So between 0 and 360, our angles that will give me cos theta equals a half are either 300 or 60. Those are my two solutions. Okay, let's have a look at another one. Alright, so let's have something, I've got something like tan theta equals 1. And this time I'm going to say it's for between, let's use the same domain, between 360 and 0. Alright, well first of all, we know that tan theta equals 1 is one of our exact values, so we know that theta equals 45 degrees. So 45 is my first solution. Again, well, where is tan positive? ASTC. Okay, well we've got my solution up here. Now I've got solution down here, but not in 2 and 4. So I'm going to have a solution somewhere down in here, so it's going to be between 180 and 270. Alright, so of course my acute angle is 45 degrees, so I think I just go theta equals 180 plus 45, which is 225 degrees. So again, I've got two solutions. I've got my one solution there, the other solution there. So for that domain between 0 and 360, I've got two solutions for this. I can put in tan 45 will give me one, and tan 225 will give me one. And the reason why we restrict this is because our curves, our sine, cosine and tangent curves keep going infinitely in both directions. So if we don't restrict it, we'd have an infinite number of answers. So that's just a little bit of reason as to why. And we'll get that more when we do some harder equations and graphing next term. Alright, let's look at another one. This time I've got sine squared theta equals a half. Okay, well, sine squared theta, that just means sine theta squared equals a half. Well, just like if I had x squared equals a half, I would square root both sides and take the positive and negative. That's exactly what I do here. I have sine theta, I square root both sides and take the positive and negative. So I have sine theta equals plus or minus, or square root of 1 is 1, on root 2. Now what you'll find here is if we look at that as two solutions, there's 1 on root 2 and negative 1 on root 2. What we're actually saying is there's going to be solutions. Sine is positive in quadrants 1 and 2, and sine is negative in quadrants 3 and 4. So what that means, we're actually going to have four solutions here. The first of which is, well, sine theta equals 1 on root 2. That's one of our exact values. They don't always come out that way, but they often do. 45 degrees. And then everything related to that between, I forgot to put down the domain, but let's call it between 0 and 360. Okay, well, I go 180 minus 45 is 135. 180 plus is 225 degrees. Pardon me. 225 degrees, and then the other one is 360 minus, which is 315 degrees. Now, if you go check all those in your calculator, if you put in sine of 45 or sine of 135 or sine 225 or sine 315, and then square your answer, you will get a half. And we will have solutions in all 4 quadrants there. The last one for now, let's say I've got 2 sine theta equals 3 cos theta. Alright, well, I can't solve that as it is. But what I could do, what happens if I divide by cos theta on both sides? And again, my aim is just to have one ratio. My aim is to end up with a ratio equals a number. And I can solve that by shifting on the calculator or using an exact value. So what would I end up with here? Well, cos theta on cos theta, that's just like a normal division. And I end up with, well, sine theta on cos theta is just tan theta. So I end up with 2 tan theta equals 3. I've still got this 2 I've got to deal with, so I've got tan theta equals 3 on 2. Okay, well, we notice that's not an exact value. Okay, I'm just adding the domain in there between 0 and 360. I mean, the pen's just not working. And, well, we don't have an exact value for that, but we can use our calculator by pressing shift and then tan 3 on 2. So if I do that, and what I find is by using my calculator, I find that my angle is 56 degrees and 19 minutes. And that's to the nearest minute. Alright, now that's of course just one solution. Again, where am I looking? I've got A, S, T, C. I'm dealing with tan. Even though I started with sine and cos, I get it down to tan. So I use tan. I've found first quadrant, first solution. I need my third quadrant solution. So I of course go 180 plus 180 plus which is 180 plus 56 is 236 degrees and 19 minutes. Now you can see, boys, the solutions are always related to one another. It's just extending that idea of angles of any magnitude. I end up with a situation where I'm trying to find multiple solutions, and I've just got to know, well, where am I looking for, a positive or a negative solution? So we'll discuss this more on Monday, but could you please have a go at the few questions that I have emailed you as well. Thanks, boys.